Machine learning and artificial intelligence, it's a very broad topic, very big field. I think Gartner says that the industry is very much still in the hype cycle. So the idea that when a new technology comes in, there's some kind of ear-pleasing words that get thrown around, and there's this idea that this thing is now the answer. So generally there tends to be a lot of hype and a lot of excitement, and then over time the actual applications that work start to settle in, and it becomes part of the fabric of how we do things as opposed to the answer. So what I want to do today is really focus on a very specific aspect of machine learning and artificial intelligence, which is its applications in demand planning. And I'll talk a little bit more about kind of how we see demand planning as well. But again, this is just to narrow on a very specific topic because, again, machine learning and AI is as broad as, in some ways, the internet. It can apply to just about anything in supply chain, depending on the use case, depending on the data availability, depending on the mathematical solving construct, and depending on whether or not it actually makes sense. So we're going to narrow in on that a little bit. What is it? I was contemplating opening with the discussion about what do we mean by intelligence anyway, but that's a little too philosophical and broad. I love that stuff, but it might bore most of you very quickly. But what it is something that looks at large sets of data, and so the benefit of it is it often can be disparate, not connected, and not similarly formatted sets of data. And what machine learning does is we'll go out and look at various sets of data and tries to build, what we'd call the relationship between correlation and causation. So in other words, when this happens over here, does that create a relationship to something over here? And not only that, but is there a kind of a lead or a lag effect? Because sometimes something happens here, but then there's not an implication or an impact until, say, 6 months later. So there's kind of a lead and lag with these sorts of things, these things as well. So what it's trying to do is look for these correlations, look for correlation and causation, and then in the context of at least of demand planning is then to be able to make automatic suggestions back in terms of how to influence the forecast moving forward. What we're going to do today is we're going to just give you a fairly finite example of what some of this looks like in forecasting and inventory optimization and in replenishment planning. The way we define demand planning is that to plan demand, it requires all of those elements. We have to have a forecast, we have to have an optimized inventory profile, and we also have to have a replenishment plan to make sure we have the right stock in the right quantity, right location, right cost, and so on. So all those are important. The tool set that we're going to show you today, at least in the US, is integrated with what's called the FRED, which is the Federal Reserve Economic Database. And so what it does is it for example, generates a baseline forecast. It also looks at history. But what it's doing is going into the Federal Reserve Economic Database and saying things like, well, given interest rates and fiscal and monetary policy, housing starts and so on, as we see that data change, does that appear to have any sort of influence on the historical demand? And then based on that, if we have a sense for what's going to happen in the future, how might we actually alter the forecast moving forward? So that's one very broad example. So what it's doing, it's literally just going to the Federal Reserve Economic Database, looking at all the relationships between the data, and then also looking at what's happening in the history of the products that this business is actually supplying, and then making adjustments on that basis. So what do I mean by big data? Again, this isn't clearly not a definitive answer. This is, again, more in relation to the demand planning aspect that we're talking about today. But I've just mentioned economic databases. So that may or may not have an implication. I know one of the companies that uses a particular technology we'll talk about today. One of the companies that used it in the US was looking at the volume of steel imports, because typically there was a lower price. So what they would see, if the volume of steel imports increased, the demand for their products would decrease. And it was usually 4 to 6 months later. So they worked out that correlation and were able to factor that into their sales and operations planning and the demand planning as well. Weather is always a big one, so particularly in retail, or maybe if we're selling a very seasonal product like ice cream or something like that. Weather can have an impact. And look, most of the cases I'm thinking about today are really more around kind of traditional retail, distribution, manufacturing, service and repair type businesses, Obviously, weather and big data, I've seen some great applications for that in agriculture, and that has a very clear implication. Now, the interesting thing about some of that stuff, though, is I saw a great case study on an organization that's based out of New York that grows food in basically inside in a warehouse. So it's all temperature controlled, and the light is regulated as well because it's artificial light. And the interesting thing is they use machine learning to work out which inputs at what times affect crop yield. Now, in that case, what I would call the relationship between causation and correlation is very clear. So there's a correlation, and you kind of know it's causing it. Now, the interesting thing, one of the questions that comes down to this is just because I'm seeing a correlation between something, did it cause it? Does that make sense? So in other words, I'm noticing that most people here are wearing darkly colored jackets. So it seems like every time we have these breakfasts, darkly colored jackets appear. So does the breakfast cause the darkly colored jacket, or is it something else? And so that's one of the questions to look at as well. As I might see a correlation, does it mean it actually is the reason? Perhaps not. Okay. So we've got things like weather, temperature, price and cost changes. So again, if we're changing the selling price of our products, if our competitors are changing their selling prices, where I think there's a big opportunity in machine learning and AI is what I call the horizontal relationships in demand planning, because oftentimes a business will say, well, if this product's increasing, it generally means that these go down. So what does that do for the overall category? So we need to have a look at that as well. So in a big data sense, if you're looking at historical demand and you're saying, here are all of my products, and I'm kind of noticing that as certain ones go up, other ones go down, well, we can start automatically building that in versus just looking at kind of a singular line-by-line forecast, because the standard approach generally is to take the history and project forward, oversimplifying a bit, line by line. With machine learning, we now can start taking a broader perspective and saying, but what's actually happening in the population of the things that we supply and sell when that sort of stuff occurs? So price and cost changes, big one. Competitor activity as well. So if you're in a very price-sensitive environment or it's heavily promotions-driven, and again, we have a sense both for what our promotions have been and what our competitor activity is as well. Again, it can make some assessments as to whether or not that's going to have an implication, and you can do some scenario planning and demand planning around that, et cetera. Okay. Interest rates, I'll link that back to the economic database type of application. Point of sale data. So what's actually happening kind of at the most granular level in terms of transactions, and can we make any relationships or correlations between what's happening with our point of sale data and that giving us some indication that, for example, well, if the point of sale data is a lot higher in the morning, perhaps there's not as much in the afternoon. And again, if we have short shelf life product and frequent deliveries, that can really change the granularity and the accuracy of what we do in the supply chain as well. Population growth. So, what's actually happening with population in different geographies? And so it might not even be growth, it might be stagnation or decline as well, relative to other parts. So if we're seeing that sort of information and seeing that into the future, what might that tell us about where to invest, what sort of supply chain resources we want to have in place, and what the delivery offer might look like as well. Customer order history. We'll talk about this a bit later and show you some things in the actual demonstration. But it's one thing to say, well, this is what our demand was, in a given period, because often with the forecasting and demand planning, we're working off monthly buckets, we might be working off weekly buckets, we might be working off daily buckets. But if we start looking at the actual customers and customer order profiles and kind of the lumpiness of that, if we start to get a clear picture around that, that can also start to help get more specific around our safety stock policies as well, and actually when we order and where we meet the customer, because again, I was at a business yesterday and had this conversation, and they were using averaging techniques. So the idea was they were a seasonal business. So as the season starts to ramp up, on average, you kind of don't have enough. Then it peaks, and then it starts to go down. And so in other words, we get the total amount right over the peak. It's just that we have half as much as we need at the start and twice as much as we need at the end. So it's not really a slam dunk, but on average, it's pretty good. So the idea is that if we get more and more granular, we can kind of get that supply chain more synchronized and aligned to that. Another one, search engine traffic. I'm seeing a lot of that with the growth of online. So a lot of the retail businesses we work with have both an online and a physical presence. And what they're saying is we can start to kind of get a sense for what's going to happen in the store when with online orders by the types of searches we're seeing, the volume of searches we're seeing, and so on. So that can now become part of an automated process in your demand planning as well. So these are just some. It's not by no means exhaustive, but hopefully that gives you flavors for some of the types of data sets that can be incorporated. Because the other thing to kind of keep in mind too, and we'll talk about some applications, is that, depending on how big this gets, there's some pretty serious computing processing, grunt going on here. So the question is it worth it? So sometimes I think doing some sort of a proof of concept, kind of building those relationships and correlations, actually seeing that it does give you some insight is a really good way to go before just kind of pushing the ship in the water. Yay! There's a few areas that AI and machine learning, and by the way, just to be clear, and the pure mathematicians in the room will probably raise their eyebrows and look at me, but when we talk artificial intelligence, machine learning, and recurrent neural networks, largely the same thing. Okay? So if I've got artificial intelligence, do I also need machine learning and a recurrent neural network? Not necessarily. They largely do the same thing. There are some, subtle differences that can be profound, but in general, it's the same idea. So given what we talked about in terms of the big data, now there's another point around this, is that to use artificial intelligence and machine learning, and particularly in the tool set that we're going to show you today, you don't actually have to have any external data. This is the other point, is that you can work entirely with the data that you have in your own organization. So one is promotions planning. So I talked about using extrinsic or external information in promotions planning. So that might look like, again, what our competitors are doing. But there's another piece, which is we planned this promotion with these attributes over this time frame and so on. This is what we thought was going to happen as a result, but then this is what actually did happen. And not only that, after we ran the promotion, we did get an uplift, but then after a while we saw a big dip in sales as well. Is that kind of what we wanted to have happen? So again, one of the good things about AI and machine learning is that we don't necessarily have to go out and start boiling the ocean. We can start just with some internal information and get a lot of value out of that. So to start getting a sense for, if we run this promotion at this time in this way, what happens, and are there some other ways of doing that? And also, do we understand, again, that horizontal impact in the business? Leading indicator analysis, you'll see an example of this today. This is one where we might do price changes, sell price changes. And again, what the technology does is basically determines if there is a statistical relationship, an actual correlation between those things. And then again, we'll recommend an automatic adjustment based on that. I think in the example we're going to see, it's not only an automatic adjustment, but it's also showing that, well, if we reduce the price of a 1.5 milliliter bottle of water closer to the 600 milliliters, some people switch out of the 600 to the 1.5. And that's good to know. Not just that it's going to create more demand, but there'll actually be a switch. Okay. Capacity and resource planning. So this is where, if we've got a situation, and it's a very broad topic, it could be in a manufacturing context, it could be in a warehousing context, and this could be around, again, seasonal peaks and troughs. It's one thing to look at warehouse capacity as, the box holds X, but a lot of times capacity is impacted by the processing capacity as well, what time things arrive, what is our put away rate, and so on. So what we can start looking at is, well, it's wonderful to basically have all this product coming in to meet the promotion, but at the same time, if we've seen some issues with capacity in the past, is it can start to look at that and start to recommend a different, say, replenishment sort of profile to suit the capacity in the warehouse as well. We've also seen some stuff. We've been doing some work recently in service supply chains. This is like in-home care and these sorts of things. So some of the applications we've seen are it's the availability of qualified staff with certain skills at a certain time to do work in certain environments. And there was some demand planning around that. But again, the AI piece is, again, looking at, well, again, we put these people into the field and they were assigned to do the work, what actually happened, and what can we learn from what we're seeing about the actual behavior of that whole process. I think this is a really exciting one, is the new item introduction in NPD. The reason I'm saying really exciting is because I'll talk a little bit about the hype and reality, because there's this kind of like, we got to do AI and machine learning, go! But, well, I tend to do this. I just say what I need to say, and then we'll get to the slide. But AI and machine learning, it's a process of subtle refinement on something that exists. So if you buy a block of land and it's got trees all over it, and you want to build a nice little country house or something, you're going to need a landscaper and a gardener. But you don't get the gardener to do the landscaping. And what I mean by that is that, and I'll show you some evidence for this as well, and I've actually heard it, I presented on this topic at the Australian Food and Grocery Council Supply Chain Seminar, and both Johnson & Johnson and Coles said the same thing, as they said, we tried to use AI and machine learning for our base forecasting. Don't do that. It's because it's too fine-tuned, it's too variable, so it kind of gets a bit erratic. And there's quite a bit of university research that says this as well, is that you need a very good, strong base statistical forecast to kind of anchor the MI to say, well, that's the forecast, and then the AI can do some refinement, but it's not the base forecasting approach. And again, we're seeing that pretty clearly. So just again, it's not like we're here and we don't have this, so we'll just jump into AI and that'll solve all our problems. It's not the way. So new item introduction in NPD is a great one, because that's an area where a lot of the traditional sort of forecasting and planning tools don't do as well. I mean, they give you the ability in a lot of cases to take history from other items, but you kind of set up that profile and you do the forecast. This is now saying, again, looking at a broader set of attributes, launch date, launch price, the amount we've made available, what discussions we've had with the customer and so on. What actually happens in terms of the uptake? And what are we seeing kind of on an ongoing basis that's happening? And then how do we use that to help to allow the AI and the machine learning to give us some information about what we can reasonably expect, as opposed to tell the machine what we expect and then plan to it that way. So seeing some really exciting applications in that area. Network inventory optimization. So again, there's a whole bunch of stuff around, route planning and sort of supply chain optimization. But what I mean by network inventory optimization is, it's not a question of the network itself, but my question is, do I have a whole bunch of, do I consolidate all my stock and ship out? Or does it make sense to hold a bit here and a little bit here, because based on my lead time and demand variability and cost, and that makes more sense? Generally what we find is businesses will make those kind of stocking policy decisions and network flow decisions, and they become somewhat fixed. They might move it every now and then, but the machine learning might look at it and say, well, actually, it might make sense to consolidate the safety stock to a point, or because the behavior of the item has changed, we now want to bring some more safety stock to this point and then change what's held at the hub. So this is that whole hub and spoke question. Do we go direct? Do we have multiple steps? That all comes down to things like lead time and cost. And so there's some pretty powerful applications in that as well. Automated replenishment and supply sourcing. The tool that we will show you today has the ability to actually look at, so what it does is it learns from planners. So in other words, as we get recommended orders, it'll build an order, say, well, here's the order, and I build it, and I kind of try to fill, I put it in layers, and I try to fill up a container, and I do some pull forward, that sort of thing, and I place the order. I've placed the order against the forecast, it's arrived, but then what actually happened? The system will actually look at all of those things and can start to automate that. And again, there's pieces. So in other words, we could say, we're only comfortable for it to do that if the order value is less than X. And the forecast accuracy is quite good, and then we're happy for it to do that, or we can open that up a bit more broadly, but again, it learns from what it's actually seeing. Always a fun discussion in forecasting and planning, which is the master data management piece, which is, that's what our history is, but we're out of stock. So one of the things that you're also seeing is AI and machine learning being used to go back and make automated adjustments to the history, to give us a better history profile to do our forward planning. So in other words, if there was a shutdown, there was a supply shortage, something happened, as opposed to having to go back and fill in the blanks, this can do some of that blank filling in a bit more intelligently. And some of the blank filling approaches that I've seen that exist now tend to be a bit crude in some cases. They just take the last point and the next point and just kind of draw a line between them, maybe not. And again, we've talked about price changes as well. Now again, there are many others. This was just trying to give you just a bit of a kind of an 8-course degustation menu for what this might look like. Where we're probably seeing the most interest at the moment, as opposed to the most actual benefit, but the most interest is, there have been the age-old questions around how do we get more intelligence around that? What happens if we make price changes? And then what about our promotional activity relative to our competitors? Surely that influences things. And that's kind of been a little bit of a subjective black art. And so there's definitely some interest in there. But that also underscores the point to me, is that I think it also overemphasizes the importance of forecasting. Forecasting is, I call it kind of the Holy Trinity in demand planning. You've got your forecasting, your inventory optimization, and replenishment planning. So far, we're with those points, we're still only focusing on the forecasting, which is really helpful, but we need all of those elements to really deliver the service and the cost and the working capital result. So, what's available? There's more than 2 blue boxes out there. But, what we've seen is, Amazon Web Services has some machine learning forecasting. So basically, you can go onto Amazon, subscribe to it, throw some data out there, and get a forecast back. Again, I'll talk about the reality in the hive in just a minute. I'd say that that's interesting. I like the idea. The issue I have is that you have to be very careful again about the use case and what you're expecting, because if we use machine learning for our base forecasting, it doesn't give as good as results of a lot of the standard forecasting techniques we have. It's a refinement process. So just keep that in mind. It's a bit like using a toothbrush to clean your windows. It's there are better ways of doing that. Okay. So there are also some systems, some integrated demand and supply chaining systems that are best of breed tool sets that I think then if we add machine learning to that, we build on it, we've got the the fundamental prerequisites already in place and then can take advantage of the next step. Thanks, Nathan. And some of the research, I actually found quite a bit of this stuff, but this was a university-based study where basically they looked at what they considered traditional, and I actually looked at what they meant by traditional. Let me back up. This was basically saying, let's take similar data sets and let's use a machine learning approach and the more traditional, just using the intrinsic history of the item to forecast forward. Looking at what they called their traditional forecasting techniques, they were pretty basic forecasting techniques. A lot of the tools that we're familiar with have things that were far more grunty than what this was. But even so, the traditional techniques outperformed the the AI, ML techniques, on a line-by-line basis. The opportunity comes to combine them. So it's not a either or, it's a and. Does that make sense? It's not a take one or the other, it's sort of the next step. It's really interesting as we heard that both J&J Coles told us that was their experience, is that at least one of those businesses actually changed their base forecasting to use that, and they actually found that it was decreasing results, so they shifted back. Whereas what Coles was saying is they're definitely still using their base forecasting approach, but they're actually using some very granular store level data, weather matched with foot traffic and things like that, to then use machine learning to feed back into the base forecast. So I just want to make that point. It's an and, not an or. So so I keep talking about the Holy Trinity in demand planning, and the core capability is the ability to generate a strong statistical forecast. And there's a whole universe of ways of doing that as well. But basically, we want something that actually looks at the historical data, does some analysis and testing, and saying this is the most accurate forecast out of what my capability set is that there is. I not only get that, I get a sense of the error in that forecast. My inventory optimization approach will take things like my service levels, my service level target, my costs, my constraints, and come up with a replenishment quantity or frequency and a safety stock that's cost optimized and service level driven. And once I have my demand plan and my optimized inventory profile, then I can start doing my supply chain planning, replenishment planning, transportation planning, and routing, but really coming up with how do I build a set of orders that, again, allows me to meet my service levels at the lowest cost with the least amount of effort. So that's that fundamental capability stack. And this says historical data has arrows going up because basically these sorts of inputs or these sorts of capabilities do use historical data and sometimes some future data to get a picture of what needs to happen. What we're also saying, though, is if we now take the big data approach, so remember some of the things I put up there before, you could put in economic databases if you want to go that far, price changes, weather changes, internet traffic, social media engines, and so on, and start to say, well, based on that, if I'm now going to run the machine learning or AI layer on that, and then bring that information into, so it's kind of a bottom up and a top down at the same time. And if you think about the old school process, that's just what it looked like. You would use the base history, and then we would use this intelligence to look at the data and say what changes. So now we're augmenting that intelligence with some additional mathematics to help with that process. To be clear, it's certainly not a replacement for human intuition insight, but again, it gives us some insights. And you mentioned a great point about the insight you got about it's actually consecutive number of days, not a monthly figure, which is really great. We can now bring that into our sales, inventory, and operations planning process because it gives us the ability to model and make trade-offs like we really haven't before. And so we've heard a lot about the need to have better scenario planning capabilities. I think this is where AI and machine learning can really help as well. So we marry those things up. But what I also want to point out is that there's a line going from historical data to machine learning as well. Why is that? Because in the tool set that we're about to show you, and again, we're just going to give you kind of just a small taste of some of these things, but what it actually does is it looks at what it forecast versus what actually happened, versus what it was adjusted to, versus what actually happened. It's also looking at what it recommended in terms of safety stocks and order profiles, what the planning team actually did relative to that, and again, what happened. And so what it does is it starts to say, well, this is what the base of mathematics tell us, but now what we're seeing is actually happening. We can now make some finer tuned adjustments within that because we're getting more and more granular data. And so again, it's kind of like your point about the number of days of certain temperature in terms of its influence on ice cream demand. I mean, it's also interesting to have the right amount of safety stock arrived on Thursday afternoon when I needed it on Thursday morning. So again, we're getting more particulate, more granular, which allows us to be more effective both from a cost and service level perspective. I'm about to hand over to my lovely colleague Luke, who's standing in the back. Before we do that, we'll just go to the last slide. So the tool set we're going to show you is one that we've been aware of for a long time. It's called GAINS. It does have that complete capability stack and has the machine learning and AI built into it. So I'll hand over to Luke to tell you a little bit more about that, and then Nathan will take us through a very curated and very short demo just to give you kind of a taste.